Hey kids. It's me, Bill.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Today, instead of science, we are going to discuss geometry. Let's start at Chapter 9, Section 1. Do you know what a vector is? Well, a vector is a quantity that has both direction and size. This is a vector. The initial point, or starting point, is point F. And the terminal point, or ending point, is point G. Now let's find the component form. The component form of a vector combines the horizontal and vertical components. So, for this vector the component form is 8, 6. We went 8 units right and 6 units up. Let's move on to isometries. An isometry is a transformation that preserves length and angle measure. A translation is an isometry. Let me show you. Let's take a look at this example. Triangle ABC is being translated into triangle A', B', C'. This is an isometry because no length or angle measures have been changed. Hello?
Bill, I need help on my geometry homework. Hurry!
I'm on my way.
I don't understand how to solve a matrix.
Don't be sad. Let me explain Chapter 9 Section 2 to you. A matrix is a rectangular arrangement of numbers in rows and columns. Each number in a matrix is called an element. To add or subtract matrices, you must add or subtract the corresponding elements. The matrices must have the same dimensions. Here is an example. To add these matrices, add the 5 to the 1. Then add the -3 to the 2. Let's move on to the second row. Add the 6 to the 3 and the -6 to the -4. As you see here, the answer should be 6, -1, 9, 10. Now it's time to multiply matrices. The product of two matrices is defined only when the number of columns in the first matrix equals the number of rows in the second matrix. The matrices are both 2 by 2. So they are defined. Multiply the numbers in the first row by the numbers in the first column of the second matrix. Look at the numbers in blue. Multiply 1 by 2 and 0 by -1. This will get you the top left answer of the matrix. Continue these steps to get to your finished matrix. Here is your final answer. Your answer should be 2, -3, 3, 28.
Wow! Thanks, Bill. That helps a lot.
You're welcome. Do you need an explanation for anything else?
I don't understand Chapter 9 Section 3. It's about performing reflections.
Okay. Let me explain. A reflection is a transformation that uses a line like a mirror to reflect an image. The mirror line is called the line of reflection. Here is a reflection. Triangle ABC is reflected over the line of reflection to form triangle A', B', C'. Here are coordinate rules for reflection. If A, B is reflected in the x-axis, its image is the point A, -B. If A, B is reflected in the y-axis, its image is the point -A, B. If A, B is reflected in a line y equals x, its image is the point B, A. If A, B is reflected in a line y equals -x, its image is the point -B, A. Here are matrices that show reflection. If you want to transform a matrix to reflect over the x-axis, multiply its matrix by the matrix 1, 0, 0, -1. To reflect a matrix in the y-axis, multiply the original matrix by TGE matrix -1, 0, 0, 1.
Thanks, Bill. You're the best.
Anytime. See ya. Hi. Are you okay?
I got a bad grade on my Chapter 9 geometry test. I don't understand Chapter 9 Section 4.
Let me help you. If I remember, Chapter 9 Section 4 is on rotations. A rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. Just like reflections, there are coordinate rules for rotations about the origin. When point A, B is rotated counterclockwise about the origin, the following are true. For a rotation of 90 degrees, A, B becomes -B, A. For a rotation of 180 degrees, point A, B becomes -A, B. For a rotation of 270 degrees, point A, B becomes B, negative A.
Wow, thanks Bill. You are so cool.
Anytime. Bye. Hey. Why are you not doing your geometry homework?
It is so hard. I don't understand it.
It is not hard. Let me show you. Chapter 9 Section 5. Apply compositions of transformations. A glide reflection is a transformation in which every point is mapped onto a point double prime. Here is a glide reflection. Triangle ABC is translated to the left and then reflected over the x-axis to form ABC double prime. The angle of rotation is 2x. X represents the measure of the acute or right angle formed by K and M. In this example we can also see that segment AB reflects over line K and line M to form the segment AB double prime.
That is not too hard. Thanks Bill. You're awesome.
I got to run. Catch you later. Hey. What's wrong?
I failed my math quiz and I can't play on the basketball team.
What chapter do you need help with?
Chapter 9 Section 6. It is about identifying symmetry.
Okay, let's get started. A figure in the plane has line symmetry if the figure can be mapped onto itself by a reflection in a line. This line of reflection is a line of symmetry. A figure can have more than one line of symmetry. Let's take a look at these examples. This first hexagon has 6 lines of symmetry. The second hexagon has only one line of symmetry. Notice that the lines of symmetry are also lines of reflection. Now let's move on to rotational symmetry. A figure has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less. This figure has rotational symmetry. Here we see the figure has rotational symmetry of 45 degrees. The figure also has rotational symmetry of 90 degrees and 180 degrees.
Wow, that is not too bad. Thanks Bill.
No problem.
Wait Bill, can you explain how to perform dilations? I do not understand that section either.
Of course. A dilation is a transformation in which the original figure and its image are similar. A dilation can be a reduction or an enlargement. The dilation is a reduction if K is greater than 0 but less than 1. K represents the scale factor. The dilation is an enlargement if K is greater than 1. Check out this dilation. The pre-image is triangle PQR. The dilation mapped the pre-image onto the new image which is triangle PQR'. Here is another dilation. Because Camp prime over CP equals 12 over 8, the scale factor is 3 over 2. Because the scale factor is larger than 1, the image P' is an enlargement. Moving on to scalar multiplication. Scalar multiplication is the process of multiplying each element in a matrix by a real number or scalar. Check out this example. Here, we have a matrix being multiplied by a scalar, 4. Multiply each element by 4. Your answer should be 12, 0, 4, 8, -4, -12.
Yay, I finally understand. Thank you Bill.
You are welcome. Good luck on your next test.